You ever stop and think about how a massive factory, or even the traffic lights in your city, all work in perfect sync? It seems, well, impossibly complex, right? But today on The Explainer, we're going to pull back the curtain and find the secret. And it all comes down to a special kind of computer, a little hidden brain that quietly runs our entire world from inside a simple metal box.
So, here's our game plan. We'll kick things off with the big automation puzzle. Then, we'll peek inside the control box to see what makes it tick. We're going to cover the language it speaks, how it thinks, and then we'll go on a hunt to see where these things are hiding in plain sight all around you. And finally, we'll look ahead to the next frontier. Sound good? Let's dive in.
All right, Section 1, let's tackle that central mystery we're here to solve.
Okay, just picture it for a second. In a factory, you've got conveyor belts moving, robotic arms swinging, lights and sensors blinking all over the place. I mean, hundreds of moving parts. So how on earth does it all work in perfect harmony instead of just, descending into complete chaos?
Well, the answer, it's a special kind of computer. It's like a tough, super reliable little brain that's tucked away in a box, and it's orchestrating every single move.
And that brain has a name. It's called a PLC, which stands for Programmable Logic Controller. Now, this isn't like the computer on your desk. This is an industrial computer, and it's designed for basically one job: to automate a process by running the same set of instructions over and over and over again, with rock-solid, near-perfect reliability.
Okay, so we've established it's a brain in a box. Fair enough, but what's actually inside that box? Let's pop the hood and take a look.
So pretty much every PLC is built from the same core parts. First, you've got the CPU. That's the actual brain doing the thinking. Then you have input modules. Think of these as its senses. And output modules, these are its muscles. Of course, it all needs a power supply to run, and you need a way to tell it what to do, which is where a programming device, usually just a laptop, comes in.
Really, the best way to wrap your head around this is to think of it like a simple nervous system. The inputs are the PLC's senses, right? They detect things like, hey, this button was just pushed. That message goes to the CPU, the brain, which looks at its program and decides what to do. And then it uses the outputs, the muscles, to take action, like firing up a motor or switching on a light. Senses, brain, muscles. Simple as that.
Okay, so if we're using a laptop to give the PLC its instructions, what language do we even use? How do you talk to one of these things? Well, that brings us to the language of logic.
And what's really fascinating here is that PLCs are kind of multilingual. There's not just one way to program them. An electrician, for instance, might use something called ladder diagram, mainly because it looks exactly like the electrical circuit diagrams they work with every day. It's super intuitive for them. But a software developer, they might prefer structured text because it reads a lot more like the traditional code they're used to. And then you've got these other visual languages, like function block diagrams or sequential charts for different kinds of tasks. The key takeaway is you choose the language that best fits the job and the person doing the job.
So once the program is in there, how does a PLC follow those rules so reliably, day in and day out? The secret is this relentless, steady rhythm. You can almost think of it as a digital heartbeat.
So how does it actually think from one moment to the next? See, your laptop or your phone is a master multitasker, right? It's juggling emails, music, a dozen browser tabs. A PLC is the exact opposite. It's a total specialist. It has one single, very specific, very fast, and very focused job to do.
And it does that job using something called the scan cycle. It's this super simple but incredibly fast loop. Here's how it works. Step 1, it checks all its inputs. Is that sensor on? Is this switch flipped? Step 2, it runs the program logic you gave it. Okay, if that sensor is on, then I need to do this. Step 3, it updates all the outputs. Okay, turn on the motor. And then it just repeats, instantly. That whole cycle, read, execute, update, repeat, happens continuously hundreds or even thousands of times every single second. It's relentless.
Okay, now that you know what a PLC is and how it thinks, this is where it gets fun. You're going to start seeing their influence literally everywhere. So let's go find some of these hidden brains out in the real world.
All right, think about the last bag of chips or candy bar you opened. There was almost certainly a PLC controlling that whole packaging line. It sensed the empty bag was in the right spot, it told the machine to fill it to the perfect weight, then it moved it along and sealed it up, all happening in the blink of an eye.
And it's not just about snacks in factories. PLCs are absolutely critical for our public infrastructure. Take a water treatment plant. PLCs are the silent operators working 24/7, constantly checking water levels, controlling all the pumps and valves. They're the reason we get clean, safe water delivered right to our taps.
And here's one you probably pass every single day.
You know that boring gray metal box sitting on the corner at an intersection? Well, next time you see one, you'll know. Inside that box, there's a PLC. And it's the brain running the whole show, managing the complex timing and sequence of the traffic lights to keep all of us moving safely.
So you get the picture. These things are powerful, they're incredibly reliable, and they are everywhere. Which leads us to our final big picture question. What's the next frontier for this kind of automation?
You know, this quote really nails it. VPLC truly is the workhorse of modern automation. It's not flashy, it's not going to grab headlines like AI, but it's the tough, dependable, unsung hero working behind the scenes that literally built the industrial world we all depend on.
And so that leaves us with one final thought for you to chew on. Now that you're in on the secret of the PLC, this simple, rugged little brain that can automate pretty much any logical process you throw at it, what do you see next? What's an everyday process or system in your life that's just crying out to be automated by its own hidden brain in a box? We'd love to hear your ideas. Thanks for joining us on The Explainer.